Okay, when we were first doing exponential, we talked about the same problem. So I do have a brownie problem. I made a whole pan of brownies. I got really hungry. They looked so good, but I didn't want to, eat all of them. So I only ate half. Only half. So I ate half. And then the next day, you remember this problem, we've done this before. The next day, I did not want to eat all that was left over, so I only ate half of what was left over. But tell me, how much did I eat of the whole pan on the second day?
Quarter. 25 cents.
And then on the third day, I did not really want to eat the whole pan, so I only ate half of what was left over. What did I eat? I ate 1/8. Could we continue this pattern without the visual?
It is 1 over
1/16
squared.
132.
What are you doing each time?
Multiplying the denominator by 2.
Okay, but instead of multiplying the denominator by 2, you could also say we're like halving each time, multiplying by half each time, but either way is fine. Will I ever eat all the brownies?
Yes.
So the answer is no.
There's a finite
So
amount
this-
of brownies, and eventually you're not going to be able to
But
split
if
and
I'm
add them in half.
Yeah, so yeah, I was right.
But if I'm halving each time, it's just going to become very, very small and smaller and smaller. So
Theoretically, yes.
really, we're never going to be able to,
Technically, no.
but yeah. So at the end of this, I'm going to put ... because this goes on forever. It goes on infinitely. Yeah. But I mean, for real, like, obviously I would eat all the brownies and leave a crumb or something, but we were writing this. Now, what we're doing today is we're doing what's called series. And a series is when you add up all the terms in a sequence.
Oh.
So if I added up what I ate every single day of this brownie pan, I would get an answer. What would I get? No?
Well, if the equation goes on infinitely, then
You were too slow.
If we started with one brownie pan, so if I ate the whole thing, I would have eaten one brownie pan. So if I add up a half, plus a fourth, plus an eighth, plus 16, plus 32, and I keep adding it, it's going to eventually add up to 1. You have your calculator?
I thought you said that you'll never eat the whole thing, but that's the whole thing, it's one, so I'm getting lied to here and I don't like it.
I don't know what you just meant, but if you do add up,
It's point.
All of that.
No.
if I'm able to add it up, I can't really add it all up because it's infinitely, but if I'm able to add it up, it's going to equal that brownie pan. It's going to equal 1.
So at some point there's a stop.
Well, it's just getting closer and closer and closer. So if you add up a half, you have a calculator, you can try it. If you add up a half plus a fourth,
You're never gonna get to 1 though.
no, but we'll get close. I am able to type this in my calculator the way I'm doing it because my calculator will automatically do division before it does addition. So it will divide 1 by 2 before it adds to the 1/4. It will always do the division first. It'll save me a little bit of time typing this in. So I've added up some of it, and you can see it's 0.996, but there's obviously some more to add up. I'm gonna have to do some powers because I don't even know what the the powers are. 9. You see how this number is getting closer and closer
If you
to
can
1?
just up, enter, and then go and change the
Yeah, I could.
Would that be faster?
Yeah, probably.
See, but you're never gonna get to one until the.
Well, I'm never going to because I can't do this infinitely many times. But it's getting closer. It's not going to get above 1. It's going to get 1, to go to 1. It's approaching 1. So today we are doing summation and series. And this was just an example to get us started on what we're doing. The first thing in our notes, now we're back in your notes, the first thing that we're going to have in our notes is how to write summation notation. Summation notation, all of the words and like the snapshot from the book, it's all in the first packet of notes. I'm just going to do the examples. So if you need to go back and look at it, it's in the first packet of notes. First thing is summation notation. Let's put a little thing off to the side here. You have some space to do it? A little picture off to the side. Okay, so summation notation is a sigma. It is a capital S Greek letter. It is not an E. It is an S. It's a sigma. Looks like this. At the bottom is called our lower index. It just tells us our first input number. And at the top, I'm just going to make up a number.
17.
Well, that would have been a fun number too, but I already wrote 6. Sorry. That would be our last input number. So when we are making a sequence of numbers, we input 1 and we get out 1. We input 2 and then we get out something. We input 3 and we get out something. We input all the way until we input 6. So that tells us the last one that we're going to input. We have to do all of them. And then over here would be the nth term. That would be our formula that you're inputting things into. So this is what summation notation looks like. So for the very first example, we have summation notation. We're going to go n equals, we're going to start at inputting 1, and then we're going to stop inputting something, but I'm not quite sure what that something is yet. I need to figure out the pattern, the nth term, to go from 25 to 50 to 75. So that's the stuff that we've done in homework 2 days now. What are we doing each time?
So, and 25 cents.
So we know it's going to be 25n, but do we have to do anything else to the 25n? So if I input 1, do I get out 25?
Yes.
If I input 2, do I get out 50? If I input 3, do I get out 75?
Yeah.
What do I input
10.
to get out 250?
10.
I put the wrong thing here. Oops. I just didn't finish writing it. There we go. Yes, 10. You're right. Okay, so that tells us that we are inputting 1, we are inputting 2, we are inputting 3, and we're inputting everything into 10, and then we stop inputting. Yeah.
So, like, on the homework, we had to do that step where we like prove, for example, that this one was, that you added 25 when I plug it in. So if you just know that you have to do this step for this step also, or?
If you can look and say, yep, 25 times 1 is 25, 25 times 2 is 50, you're fine. If you can't figure it out, then you need to start, plugging numbers in and trying other numbers. Some of them will be easier, some of them will be easier. Okay, next one. Oh, so that's it, by the way. Everything in blue, that's the final answer. Come on. There we go. So the part in blue is the final summation. Next one is a fraction. So remember, when we have fractions, let's look at the top part and the bottom part separately. We're going to have a summation. We'll start at, what do you want to start at? 1. What are we going to end at for this one?
Infinity.
The dot, dot, dot means it's going on forever, so we're going to have an infinity up here. So this is an infinite series. Now think about your input number and figure out your output number. Look for common differences. Right on top, if I input 1, do I get out 1? If I input 2, do I get out 2? If I input 3, I get out 3. What is on top?
1 or n.
N. 1n, right? On the bottom, if I check my differences, those are also plus 1. So there's going to be a 1n, but it's not just n by itself. How do I input 1 and get out 2?
Plus 1.
How do I input 2 and get out 3? How do I input 3 and get out 4? Plus 1. So that would be our summation notation for that one. Okay, there's 2 more, same time. Should try it. This one's right, that one's not. It does look like kind of an E, but it's not. People call it the E, but it's not. If that helps you draw it better. Yeah. You made like a V or S or something.
Do you have to start at 1 and you change that?
You can change that. Did you change it?
Yeah.
Yeah, that's fine. So what do I know for sure about this pattern? The fraction.
It's always on top.
2 is always on top. And we look at the bottom, we say,
5, 6, 7,
add 1,
8,
add
9,
1,
10,
add 1, it's got to be 1n. How do I input 1 but get out 5?
You just start at 5.
How do I input 2 but get out 6? Add 4. And then at the top, when do I stop inputting numbers? I don't, so what goes on top? Infinity on top. So this would be our formula. Now, Jarrett is impatiently yelling out answers over there. He asked me if you can start at a different term. The bottom number just tells us which term we start at. He started at 5 and went to infinity. And his formula looks different because he started inputting at 5 first. So if your first input number is 5 and the bottom number is 5, it's going to be like 2 over n. If you input 6, then it'll be 2 over 6. If you input 7, then it'll be 2 over 7. So he just started inputting at a different number. I feel like that may confuse some of you more. You can do it, but that might confuse some of you more to start at something different. Okay, the next one has something that we did on Friday. What's kind of special about this one?
It's alternating.
It's alternating plus or minus. So we talked about if we are multiplying each one by -1, you're doing times by -1 each time. I mean, that's not the only thing that's happening, but that is happening. Then we're going to have to do -1 to the n power. Does that work for 1? If I input 1, do I get out -1? If I input 2, do I get out a positive number? And that doesn't give me 3, but does it give me positive? If I input 3, does that give me a negative number? You have to check and make sure that that's working. And then we're going to have to do our summation. We're gonna start at 1. What are we gonna go to? What input number am I stopping at?
9.
No, I'm stopping at my input number.
Oh.
You can't see
5.
5. So we are inputting 1, 2, 3, 4, and 5, and then the output number is what they've given. So we know that this is -1 to the n, but we don't know the rest of the formula. So we gotta look at this formula. How do I go from 1 to 3? Plus 2. 3 to 5, plus 2. 5 to 7, plus 2. 7 to 9, plus 2. So this is gonna be 2n. Is it just 2n?
No.
So how do I plug in 2 times 1 but get out 1? How do I plug in 2 times 2 but get out 3? What do I have to do to it? Minus 1. So I'll have 2n minus 1 is the rest of my formula. I put those in like separate parentheses because you have to have both of those answers, then multiply them together. So it's the same stuff we were doing yesterday, you just have a fancy symbol in front. All right, questions? We can do this. The last part of the notes is finding the sum. So it is called a series when we're adding them all up. It's called a sequence when there's just commas between them. But it's a series when we're adding them all up. So we're going to actually find the sum. So for the first example, they use different letters. I always use like N, but they'll use different letters. So here's K equals 4, and then at the top it has 8. That is telling us that what is our first input number? We're going to input 4, so we're going to do 3 plus 4 squared. What is our next input number?
5.
3 plus 5 squared. Then we input 6. Then we input 7. Then we input 8. And we stop because 8 is the last input number. That's the last number I'm putting in to the equation. We're going to find each of these answers. It's going to be 3 plus 16, so 19. 3 plus 25. 3 plus 36. Plus 49. And 3 plus 64. And then we are finding the sum, so you will just add together 19 plus 28 plus 39 plus 52 plus 67. Yep. 205 would be the answer for that one. And then the one next to it, same kinds of question. Yes? When does it always equal 1? From? Well, that was infinitely. That was an infinite time, and also it was the specific thing that was multiplying by half each time and starting like what your number is starting with that way. It doesn't always come out to be 1. Just that one particular example came out to be 1. Okay. The answer could come out to be. I could show you one that comes out to be 7/10. Or no, it would be like 7 or 8. Like I have. There's other patterns you can get. The ones that we're going to do are going to have answers that you can easily come up with. Okay. The brownie one you came up with because I told you what we started with. Next year in pre-calc, you'll have stuff where you're going to figure it out. All right, so for this one, what is my first input number?
0.
So I'm going to do 0 to the third, then 1.
And 2. Correct. And 7.
Whoops. And then 4. And then that's when I know to stop, when I input that top number. So then I have to add up all my answers.
And it's component.
Yes.
So this, how do you get it per time? What do you want to say?
We're not going to get today. This is our last lesson. We're not going to get majorly into it. I don't think I gave you any within. I better check. I don't think there was any within.
Better check.
Yeah, we're not doing that yet. We're not doing that this year. Yep. So the last example is sometimes there are shortcuts.
No.
Yeah.
So you do not have to use these shortcuts, but they save you time. So there are three particular examples where you could use shortcuts. The first one would be if you're taking the sum of a bunch of terms, but every single term is 1. What?
We have to do the shortcut.
I just said you do not have to do the shortcuts. But if you do not want to do the shortcut, please do C by hand
Okay.
while I'm explaining the shortcuts. Okay. So for the first one, it's when the formula is 1. Like the formula literally is 1. That's the formula. And then if that happens and it goes from 1 to n, you just put the n for your answer. The second one would be if we're adding up the first n positive integers. For example, can you add up the first 100 positive numbers, positive integers? From 1 to 100, can you add them up? You can. How are you going to do it?
1 plus 2 plus 3 plus 4.
How are you going to do it by hand? Are you going to type in your calculator? How are you going to do it? It's going to take a while, whatever you decide. So there's a shortcut that says if you know how many of them you're adding, like my example was 100, then you would put 100 right here, and then you would do 100 plus 1, and you multiply them together and divide by 2, and that'll tell you your answer every time. So it's just a shortcut. And then the last one would be if you're adding up the sum of squares. So like it would be 1 squared, plus 2 squared, plus 3 squared, plus 4 squared. This would be the sum of the squares up to however many. And you would take that number, multiply by that number plus 1, and then multiply by 2 times that number plus 1, all over 6. So here's 3 examples of those 3. The first one, you see there's a 1 right here. There's a 1 right there. The answer is going to be 35. Because each term is 1, and I'm doing 1 plus 1 plus 1 plus 35 times. 35. B, this is saying that we're going from the first input to the 16th input, and the formula is just n. That's just the number itself. So this would be adding the first 16 positive integers. So we're going to use this formula. You can add 1 plus 2 plus 3 plus 4 plus 5 all the way to 16. You can do that. Or you can do 16 multiplied by 17 divided by 2. (16 times 17 divided by 2, 136. 136. And then the last one, this says to take the first 18 numbers, square them, and add up all the numbers. Have you done it yet, Brandon? He has not. So we're going to use the formula that says to take
Big number.
n, 18,
Big number.
multiply that by 18 plus 1, and multiply that by 2 times 18 plus 1, over 6. So 18 times 19 times 37 divided by 6. 2,109.
Did you get that, Brandon?
Yeah. Big number.
Did you get A and B yet?
You didn't get it.
Bench.
You got it when you typed that in.
I had to make sure you're right.
Uh-huh.
Because we can see.
Well, I appreciate you checking my my work, because I do make mistakes once in a while.